All right, Jane, we are recording.
As I said, welcome everybody. We're delighted to have you here today. And Charlie has been so kind as to offer up this particular program today. Before I introduce him, however, I'm going to let you know we've had a change in schedule because our program for next week, she had a major conflict that popped up and asked me if she could do it next spring. And I said, fine. So I volunteered to do one on the state of our union. Um, and for a brief concept, the U.S. Constitution provides for three co-equal branches of government to provide checks and balances against overreach by any branch. We will discuss how this has been working in recent years and over the last 10 months, and what steps will be required to rebalance the branches. I felt this was particularly contemporarily of import and welcome you to come, regardless of your point of view. Um, I am an attorney, retired, worked for the government, worked for the Urban Institute as a consultant to the government and to state and local governments. This was way back when, but it's been given me valuable
Excuse me.
insight. And in any event, I look forward to seeing you then. For today, I am absolutely delighted to welcome my neighbor Charlie. Anybody who's a neighbor of mine is in deep trouble because I say, "Would you mind?" But he's a senior engineering geologist with Caltrans Geotechnical Services. He was hired by Caltrans in 2000 and is a licensed professional geologist and certified engineering geologist in the state of California. He is the branch chief for the Geotechnical Services Group in Eureka and has served as chairperson of Caltrans statewide landslide and rockfall technical team. Team? Teams. He has a bachelor's degree in geological sciences from the University of Maine at Orono and a master's degree in geology from HSU. He's passionate about his work and excited to share information regarding landslides in the North Coast region. And now it's all yours, Charlie.
Good morning, everyone. See if I can get through the first hurdle here of sharing my PowerPoint presentation. So let's see if we can do that with ease here. So I'm going to share. Give me one moment, please. So let's see. Give me 1 second and share. And let's go here. All right. Does everybody see that
You
all
got
right?
it. You got it.
All right.
Go
Whew.
for it.
That's the hardest part, right?
Yeah, we always ask everybody to come on board early so we can play and
Yeah.
make sure the technology is working
Yeah.
because often it's an issue. And
Yeah.
Charlie will explain you're welcome. He welcomes questions and you can put them in the chat or obviously raise your hand. I will be monitoring the chat and so he doesn't have to um,
Yeah. Yeah, feel
and
free.
interrupt
Yeah.
as needed. Okay.
Well, welcome everybody. Certainly enjoy this opportunity to share some information about landslides here on the North Coast. Something that we're all maybe more familiar. Some of us are more familiar with landslides than others, but I thought certainly hear it in the news, and anybody that lives on the North Coast at some point has probably been impacted by a road closure or delays related to landslides. So it seems like it's relevant to folks that live here on the North Coast. Yeah, and the point in all this is for hopefully people that sit in on this today learn something. So feel free. I'd like to keep it informal. Feel free to interject. You could just interrupt me. I don't mind. But if you'd rather use the chat, it sounds like Jane might be monitoring that, and she can interject when there's a pause or when appropriate. Yeah, again, I want to keep it informal. I might have to pause a few times. I had the crud last week, so I'm still getting over the. You might hear it in my voice, but so I apologize if I have to pause and drink some water and take a pause every now and again. But I'm glad I was able to participate today. So living with landslides, the hardest thing I think in giving talks about landslides is really what to focus on because they involve a lot of there's a lot of different things that you could discuss that pertain to landslides, from why they occur to how we mitigate them to how they impact our lives here on the North Coast. And so for today, I thought I would just kind of give a kind of a short introduction to, the different types of landslides that we have here in Northern California, kind of the nomenclature, the way that we refer to them, the kind of the classification scheme that we use just to describe them. So we're talking about the same things. Um, and then I just thought for today, people might wonder, how do you decide for any given landslide how to mitigate it? And so I'll talk generally about types of kind of generally the broad approach to landslide mitigation. Um, and then I'll provide a few examples. And I think there'll be ample time for questions. So again, don't hesitate to inquire. So you might wonder where this lovely picture is taken from. So this is out on Highway 96 out near Orleans. And you can, down here, you might be able to see what look like some fences. These are rockfall fences. And there's some cabling over here on the left-hand side of this picture. Most people that drive this stretch don't even know any of this infrastructure exists or this hazard exists above the highway. But essentially, we've lashed some very large boulders to the hillside, so they are anchored using cable nets and cables. They are lashed to the hillside. And then we also have these rockfall fences that are well above the highway to intercept rockfall that emanates from this rockfall source area before it gets to the roadway. And so there's a lot of I'm hoping this will be kind of insightful for people too. That might be like, wow, I didn't even know, Caltrans does this stuff and that some of this infrastructure is out there. Some of it's self-evident from the roadway, but there's a lot of places where I'm sitting here about 1,500 feet above the roadway where we've got a lot of rockfall mitigation infrastructure in place. It's a beautiful spot to work too, so thought I'd start with that one. So, what is a landslide? I mean, we might all have different perceptions or ideas of what a landslide is, and I think according to Cruden, 1991, probably the simplest definition is and let's see, I've got a pop-up here that's blocking my view of my own slides, so let's see if I can get rid of that. But essentially, oh, hold on. Yeah, so the term landslide usually is used to describe movement of a rock mass, debris, or earth down a slope. So I think that in simplest terms, you can think of it as rock, debris, which typically is used to describe a combination of both boulders as well as soil. And earth is oftentimes used to just describe kind of fine-grained material. So, but in simplest terms, it's, a mass of rock, debris, or earth down a slope. And I want to make note that landslides don't occur only on land, but they can also occur underwater. And then Varnes, 1978, came up with I think one of the more simple classification schemes for landslides. And I just want to highlight, so any landslide can be classified and described by two nouns. The first describes the material, and the second describes the type of movement. So, pretty simple stuff. It's not too complicated. So when we're referring to landslides, and there's some very sophisticated landslide classification schemes, but in simplest terms, we typically describe them in terms of the type of movement. So is it a fall? Is it a topple? And I'll give examples of each of this: a slide, a spread, or a flow. So a fall is, if you can imagine a rock comes bounding down the hillside, we call that rock fall. It's falling, through the air, and it might intercept the ground surface as it bounces down the hillside. Topple is when there's like an overturning moment where you might have rock that is fractured vertically, and there's what's called an overturning moment where the material is actually falling in rotation, kind of, and they call that topple. We don't see that very often. That typically happens in rock. Slide, I think, is pretty self-evident. We have a lot of slides in our neighborhood, or in this part of the world, where literally the rock or soil is sliding on some failure surface. That might be the one that people are probably most familiar with. Spreads are typically where the failure surface of the landslide is very gently dipping or flat almost. Sometimes these happen during earthquakes in saturated material where um, the land, due to groundwater and other forces, can spread essentially, in more of a horizontal sense. In flow, we also get debris flows in this part of the world, and that's what you often see occurring in Southern California during large, atmospheric rivers where you just see these torrents of debris and mud that come flowing through canyons and oftentimes occur in recently burned areas. So nothing fancy, so the first term is type of movement: fall, topple, slide, spread, flow. And then just very generally speaking, in this simple classification, is it rock or is it debris? So if it's predominantly rock, you might call it a rock fall or a rock slide. And if it's debris, which again tends to be a combination of both fine grain and coarse material, which is pretty common up in this part of the world. Oftentimes the landslides are comprised of not only soil, but they incorporate a lot of larger boulders in these landslide bodies, and we call that debris. So you can get debris slides and debris flows. And so, so I'd say the ones that we're probably most accustomed to seeing up here are rock falls and rock slides. And then uh, on the debris side, we have debris slides and debris flows, and I'll share some examples. So I was going to try to set this up where we could do a show of hands and do a quiz, but I was pressed for time, so I'll just walk you through these. But this is an example of a debris slide. So you can see maybe some boulders here, some larger blocks. There's some soil. The brown stuff is probably the pedogenic soil that the vegetation was growing on. It's got organic material in it. And then we also have a lot of rocks. So we've got a combination of fine and coarse material. So we're going to call that debris. It's not just rock. And it slid. And this is for those of you that have been here for some time. This is an old picture from Confusion Hill in Mendocino County, but this is a debris slide. And why is this important? At least when you're in the industry and it's your job to mitigate landslides. And I said, why is it important? Because words have meaning. So I think it's important if I was to receive a call from one of our field maintenance people or somebody on my own staff, and they say, Charlie, highway's closed, we have a debris slide. So it's important that I understand the circumstances. And so when somebody says debris slide, I immediately can associate that with, the actual landslide. Or if they say, hey, we've got a debris flow, then that has a whole different implication. And so I think it's just important that because there's so many different types of landslides that when you're a practitioner and it's your job to mitigate them, it's important in our industry that we have some uniform, systematic way of referring to landslides so that there's consistency in not only how we refer to them, but they oftentimes have very different mitigation strategies. So you don't want one person's debris flow to be somebody else's rockfall, so it just creates confusion. But anyway, so we have there's a good debris slide. So this looks a little different. This is kind of more of a soupy mess. These can be really challenging to deal with. It's kind of a little different beast, as I like to refer to these landslides as beasts that we have to deal with. So this is what we would call more of a debris flow. Some people call these mudslides, but this is where we do have some rock, but this is predominantly finer grain material that's saturated and it flows and it's coming down this. This is out on Highway 96, again, out near Orleans, but this is what we would call a debris flow. And I can tell you, these are a real bear to deal with. And this is something you oftentimes see in the news in Santa Cruz, in Southern California, particularly post fires when we get intense rainfall. You oftentimes see these debris flows. And then here's a good example of this is a whole different beast. So this is a rock, that's a really large rock that came off that hillside. And again, this is out on 96 where you get all kinds of action out there. But so this was a rock fall. And certainly what you do to mitigate a problem like this is a lot different than the debris flow you saw on the previous slide. And then this was what we call a rock slide. So it was predominantly composed of rock. It wasn't just it wasn't one singular rock that came bounding down the hillside, but we actually have this on video where this was a large rock slide, which this was after the fact. And I'm trying to remember if this is the outboard edge of the roadway or the inboard edge, but basically this location buried the highway in all this rock. So anyway, I just thought people might. So if you hear that, and I can't guarantee that what you hear in the news is accurate, but but it might help people when they hear, "Hey, there's been a debris flow or a rock fall." It might just help people to understand what those terms mean, and that's kind of what they look like. So, and this is just a typical. This is a block diagram. I might be using some terms that people aren't familiar with. And one size does not fit all. As you can see, there's quite a broad range of situations I just showed from that rock fall with the large rock in the middle of the lane versus like the debris flow, which covered the highway with mud. But I just thought it might be because we're all trying to learn something new here, hopefully for some folks, or learn something that they've already heard in the past. But oftentimes we refer to landslides as having a head scarp or a main scarp. That's typically where the head scarp or the landslide starts at the top. There's some displacement of the earth that usually results in a large oversteepened scarp at the top. And what the landslide is sliding on or flowing on, we usually refer to that as a rupture surface or the landslide failure surface. So oftentimes you might hear me talk about the depth below the ground surface to this landslide failure surface. And sometimes you get intermediate or minor scarps. And then down here, usually, and then oftentimes there's a zone of depletion or evacuation. And then all that material, after it's either slid or flows, it's got to go somewhere. And usually it ends up being deposited in the zone of accumulation. And we call that kind of the toe oftentimes. So this is kind of the head of the landslide. This is the toe, the landslide failure surface. And then there's a host of different features that might be displayed depending on the type of landslide. But I just thought that might be helpful. And so I like to tell the story that oftentimes I'll show up on a job site, often when the highway is closed, and either the road has been taken out by a landslide from landslides below the highway, or it's completely buried the highway, or it's started above, took out the highway, and continued all the way to the river. So but it's funny that I'll show up and obviously people are concerned and anxious to figure out what we're going to do. And the first thing they say is like, "So what are we going to do?" And I always say, "I don't know. I just got here." So, it's usually takes some investigation, but I've been working up here in District 1 for the last 20 years. And District 1 is Humboldt, Del Norte, Mendocino, and Lake counties. So that's kind of our jurisdiction. So we get a lot of action in those 4 counties. But so the first question is, well, what are we going to do? So landslide occurs, it has impacted our infrastructure. And so what are we going to do? And so some people might think it's really complex, and every landslide is different and has its own unique set of challenges. But in order to simplify it, I typically will start by telling people, well, we like to approach these in terms of avoidance, stabilization, and protection in the realm of rockfall, and then management. And so it can be overwhelming, but if you kind of start broadly, then you can start to narrow down your options. And we're going to talk about each of these and I'll give some examples. But avoidance. So what is avoidance? Because that's usually that's going to be your best option in most cases. It's usually the most expensive and has the most impacts. But if it's a real bad actor landslide, avoidance is a really great approach. And so what is avoidance? So this is an example from in Mendocino County on Highway 1, and this is a great example of avoidance. This is an aerial view of South Fork Eel River, and this is what used to be where Highway 101 used to be at Confusion Hill, which I'm sure most folks on this call, if they've lived here for any length of time or prior to, I guess, mid 2000s or around 2005, prior to 2005, they were familiar with Confusion Hill. And so this was a stretch of Highway 101 that has a large landslide complex. I don't know if people can see my cursor, but I think you can see the denuded areas where the trees have come down over in the past, and now we're left with these raw, steep kind of soil, rocky slopes above the highway. But for decades, there's a large landslide complex here that every time it moved, it would rain debris all over the road, both rocks and debris slides and debris flows. And after decades of studying this, we tried to protect the roadway by constructing debris flow fences and rockfall fences along the inboard ditch of the highway. And most of those worked with limited success, and they would be overwhelmed by these large slides. And really, there's no room to move the highway here at its current location because we have this steep eroding slope below the highway. So we said, well, we can't. It's too big to stabilize, and the protection that we tried to put in place only works so well, but we were still faced with frequent closures. So we thought, well, can we avoid this slide? Oh, and here's just a picture. This was common at Confusion Hill for many years. We'd have this K rail in place, and these are posts of a rockfall fence that got bent over. You can see one of these shower curtains, as I like to refer them, this what we call a cable drape, which is a big heavy cable drape that's draped over the slope to try to mitigate rockfall coming off the hillside above. But so despite our best efforts, protection measures usually it wasn't futile, but usually they would be overwhelmed, and this was a common occurrence. And so stabilization and protection along the existing alignment just wasn't really an alternative. So Caltrans decided, with the help of Federal Highways, that it was time to find a long-term solution to Confusion Hill. And so this is an aerial view now. We're looking from, this image was taken from an aircraft looking down at the South Fork Eel River. The yellow is old Highway 101, or was the existing Highway 101 at the time. And these lines over here, these different colors, we got a blue and a red and a green, these were alternative alignments that Caltrans considered to essentially bypassing the old Highway 101 alignment and avoid the Confusion Hill landslide. So this is like a classic example of avoidances. So we had a giant landslide, caused us all kinds of grief. I can't tell you how many times myself and my family and probably all of you got stranded on one side of this trying to get to the Bay Area over the holidays for an air flight, to go catch a flight or visit family or coming back from a trip, and you'd end up having to go through Bell Springs Road on some awful detour in the middle of the winter. But so ultimately, Caltrans had selected an alternative alignment and built two bridges, one here and one here over the South Fork Eel River. Again, I'm not sure my cursor's working, but
It is. It
oh,
is.
great. Okay, yeah. So this is just a classic of example of avoidance. We had a landslide that was causing us a tremendous amount of grief. It cost an enormous amount of money and there's also the safety concerns to maintain this section highway. And the decision, which was not an easy one, and it took decades to develop this, mitigation strategy, was avoidance. So there's a great example of avoidance. And for those of you that are familiar or have been following kind of the updates that have been coming out in the news about last chance grade up in Del Norte County, south of Crescent City, north of Wilson Creek. So that because of the magnitude of the last chance grade slide complex along Highway 101 in Del Norte County, a tunnel has been proposed to essentially bypass the worst portion of the last chance grade slide complex, thereby avoiding it. So so history repeats itself. So this avoidance measure was designed and built back I think we started in 2006, and it took about 3 or 4 years to complete. But here we are in 2025, and we're talking about doing a bypass or avoiding the last chance grade landslide. And that's supposed to go to construction, I believe, in 2030. So history repeats itself. But anyway, and then here's just an aerial view. It's a little blurry. I got this off of Google Earth. But here's the old alignment, which was decommissioned, meaning we tore up the asphalt and removed the retaining walls. So there's the old alignment, and then here's the new with our two new bridges. And people just buzz right through here, and you'd never even know that for people that are new to the area or don't have any recollection of Confusion Hill landslide. Now they just come flying through on these gorgeous new bridges and never give this another thought. So there's an example of avoidance. And Jane, I'm not looking at the chat, but does anybody have any questions at this point? Or does any?
Yeah, John Clark mentioned
Sure.
they moved here 18 months ago around Elk River Road. They're on a very steep hill with sheer slides. Is there an entity that could evaluate the chances of a landslide and recommend mitigation? In other words, does the state do that? Do you do that?
Yeah. So Elk River Road would, I believe that's probably outside of what Eureka city limits, but it's probably within Humboldt County jurisdiction. I'm just guessing, but I'm guessing Elk River Road, and I was just out there for a mountain bike race this past weekend, out on Elk River Road. And I'm guessing that falls under the jurisdiction of the county maintenance, Humboldt County Maintenance. And they certainly have um, some battle-hardened people that work for the roads department for Humboldt County in terms of being proactive and being able to do an evaluation and come up with slope stabilization measures. I know, as we all probably live here in terms of paying our taxes, know that a lot of their funds come from tax revenue, so they're pretty strapped for funding. So unfortunately, I think the county has a hard time being proactive in terms of mitigating some of their landslides, and oftentimes it's more in response to, but it's hard to find, even for us Caltrans, believe it or not, it's hard to find funds available to proactively mitigate landslides. And unfortunately, oftentimes there's a lot of funds available after it's occurred, but it's hard to find funding to be proactive. But if he or whoever asked the question, certainly if you wanted to inquire, um, I know some of the people over at the Humboldt County, because they're the Division of Maintenance, the roads department, they've got some, like I said, some really outstanding individuals over there. And certainly, I always encourage people, if you see things out on the road, whether it be, county, city, state highway, and even if you don't know what the jurisdiction is, I mean, oftentimes it's great when the public will notify Caltrans and bring it to our attention, like, because it's better, it helps us to be able to be made aware of issues that are developing, because then our maintenance crews can monitor these locations. And so the county may actually, um, they might be aware of the location, there may be a plan for it, or it might be something that's new to them. So hopefully that answers the question, but I think the Humboldt County Maintenance Department and their roads division would probably be the best person to try to touch base with.
I have a question
Yeah,
related to that. If you own this property and you're worried about something that's on your property,
yeah,
can you get consultation from the
yes,
county
yeah, and so
in
yeah,
order
maybe
to say this is a problem or not a problem? And then who's responsible for paying for the problem if it's
yeah,
on your
no,
land?
and thank you for, and I think thank you for the clarification, maybe on the question too. Is so if you've got a landslide on an adjacent property that's potentially going to impact yours, or it is impacting yours, or you have a developing landslide on your own property, there's some there's SHN is a local engineering and geotechnical consulting firm in Eureka. They certainly do. They could certainly do an assessment, like a landslide evaluation. Um, we used to have Lako Associates, but I don't think they have a geotechnical division anymore. Um, but certainly SHN consulting engineers and geologists, they work with a lot of private landowners in this area, both basically to address landslides. Uh,
So I'm presuming if the landslide starts on your property, you're responsible for the damages that it causes to your
it,
neighbors.
it can be very litigious, as you could well imagine. I've spent, done expert witness work, and so oftentimes you have to, and so wasn't going to talk about that today so much about the cause of landslides, but the first order of business is typically to determine what caused the landslide. So it could be like if there was some kind of uncontrolled drainage coming off your neighbor's property that was responsible for the landslide that occurred on your property, then they in that case might be liable. Um, so the first order of business oftentimes in terms of figuring out who's going to pay for it is to determine the cause. So that and I guess without going into too much more detail, but that's why it's important to have I would say like a licensed geoprofessional, either a geotechnical engineer or an engineering geologist to evaluate these landslides and then make, professional judgments or, determinations about what caused the landslide. And then if it's not an active Mother Nature, and it's attributed to grading on an adjacent property, meaning like large scale earth moving or disrupting natural drainages or concentrating surface flow due to anthropogenic activities, then oftentimes there are lawsuits and litigation related to landslides because essentially, somebody's activities on their parcel may have resulted in generating or creating a slope instability situation on an adjacent parcel. So it kind of depends on what caused it and if that was by natural means or if it was due to anthropogenic considerations. And then that kind of gets to the root of the problem about who's paying for it.
Please explain anthrogenetic.
Yeah, anthropogenic, I think broadly it means any, I guess, alteration of the landscape by human activities.
Oh, okay,
So,
thank you.
so yeah, in this part of the world, oftentimes there's a lot of grading, meaning there's people that want to create flat space in an otherwise hilly landscape. And for years, we've had a lot of unpermitted grading. So typically, a grading permit requires that you go to the county and get that approved. So if you're going to do any significant alteration of your landscape on your property, it usually requires a grading permit. But for many years, there's a lot of folks that didn't get grading permits, and so it's not under the purview of the county or it wasn't reviewed by a licensed engineer or geologist. And oftentimes those unpermitted, I'll say, earthwork activities result in significant drainage issues and oftentimes trigger landslides and debris flows for the folks downstream. Um, so if you ever see your neighbor like, laying to waste the hillside above your house, you might inquire if they've got a grading permit or it's good to pay attention, right?
So we're downhill from the plumbing that goes along capturing water flow, rainwater flow on the streets. And if there were a leak in that system that, uh, I don't know, do they check for leaks in the system that cause water to flow downhill toward our house?
Yeah, I don't, that's
Be
a good question.
responsible?
Um, I don't know how frequently, say the county or the city checks their storm drains, but storm drains are sometimes a culprit. If a drop inlet, like the grates that you see that are, capturing all that runoff, rainfall runoff, when they get
Yeah.
plugged and that water jumps the curb and it's concentrated on a steep hillside, it can start as a gully and then oftentimes, depending on the magnitude of the discharge or the flow, it can, if you get concentrated surface flow, it can result in incision and in some case be a trigger for small debris flows. So, um, yeah, and it's not doomsday, right? I mean, they do occur. Uh, most, I would say probably all housing developments typically, there's a lot of geotech that is done during the course of developing that housing development in terms of looking at the types of soils, what's going to be required for the foundations, setbacks from steep, potentially unstable slopes. And then certainly in this part of the world, we also have seismic, earthquake considerations, ground shaking, tsunami inundation. We have liquefaction potential, which is I remember just funny stories when we moved. My wife and I met in graduate school at Humboldt State probably 30 years ago, and we moved away for a brief period and then came back. And when we were house hunting, and we told our realtor that we were geologists and we didn't want to be in a tsunami inundation zone, we didn't want to be in a liquefaction zone, no known earthquake hazard zone or landslide. She's like, I don't think I'm going to be able to find a place in Humboldt County that meets your needs. So, yeah, it's a tough neighborhood, as I like to say. So how are we doing on time here? So that's avoidance. So avoidance is, and were there any other questions at this time? Oh,
Well,
none.
there's
Hearing
just
none.
a comment from Alice that my uncle Heinz Heckeroth was chief deputy director of Caltrans in the 1980s. We would camp at Standish Hickey. He was so proud of the great work Caltrans did for that bypass.
Oh, cool. Yeah. Awesome. Thanks for the comment. Yeah, it's a lot of times when people come up on a road closure, um, they're kind of annoyed because they're delayed getting to where they need to get to. Um, but just, I guess I'm not getting on my soapbox, but try to be patient and appreciate the level of effort that our field maintenance people and engineering folks and hydrology folks that takes an enormous amount of effort to keep the highway open in this part of the world in a wet winter, and to do that and maintain safety for the people that are working on the ground. And I think rural communities are more appreciative. Usually when you have closures in more of our metropolitan areas that are due to landslide mitigation, we get a lot of people flip you the bird and they get on their horns. But, for people that rely on like out on Highway 96 and Highway 169, some of our secondary routes, people that, really rely on these routes for their livelihood and safety, are a little more appreciative. But yeah, but thank you for the comment because, yeah, he should be proud because it's an enormous amount of effort and there's a lot of hardworking people that are out there that are, day in and day out keeping the road open and safe, particularly in this kind of environment. So stabilization, so we talked about avoidance. Confusion Hill is a great example. Last chance grades, kind of if the tunnel gets built, there'll be an avoidance approach. So this one I wanted to share. Some of you may remember this one. I just thought this was a good example. I could do some recent ones, but this was a cover of the North Coast Journal. I guess it was called the Journal back then. What year was this? This was a while ago. I'm trying to think, maybe I've got a date in here somewhere, but this could have been 2011. But this was a large landslide that came down and basically buried a four-lane section Highway 101 down near Dean Creek, the hill that ate 101. So this is a big landslide. I can't recall off the top of my head how many thousands of feet in length this was. But this is where I had shown up down. I showed up as the highway was closed, and I got called out to go figure out what was going on. And at that time, all four lanes were covered with debris. And everybody said, "So what are we going to do?" I said, "I don't know. I just got here." So I said, "We don't even know how far this thing goes up the hillside." And so a partner and I, with our camera and some surveying equipment, started marching up the hillside. And I remember getting to about midway, thinking that this was the top, and we got up onto this bench, and then I realized it went for another 1,000 feet or more up above, and that's when I knew we had a even bigger problem on our hands. But and here's just another. So this is I showed a little block diagram earlier. This is the head scarp up here, and here's the toe. And underneath all this moving earth is what we call the landslide failure surface. So maybe you can envision that diagram I showed, that all this real estate was moving and it buried the highway. So there's just an aerial view, but here's some down here in the lower right-hand corner, you see some little yellow Tonka trucks. So that looks like an excavator and maybe a bulldozer or a small cat. And and this is just the upper portion of the slide, so that just gives you an appreciation for how big this was. Just another picture of the debris. So I would call this a debris slide. It was a combination of both soil and coarse material. So this is more like debris. It's not all rock and it's not all soil. It's kind of a mixture. And these were just these intermediate scarps in the body of the landslide. The interesting thing is when we were standing here, the slide was still moving. It's kind of exciting. You might wonder if we had any common sense, but anyway. And so this is a cross section, and it makes basically if you were to cut this landslide vertically and then look at that vertical slice, this is kind of what it looked like in cross section. So to kind of bring this back to what I was trying to get to about this talk about avoidance, stabilization, and protection. So this was what we felt like this was a landslide as big as it was. We felt like we could stabilize the landslide. So we couldn't really avoid it. We have the river on the downslope side. We needed to get the highway open. It's a 4-lane section. Highway 101, our one of our probably our biggest route here in District 1. And so the idea was to, and this is just what it's shown on paper, is that we were going to excavate the toe of the landslide, and we were going to and then we were going to dig below the failure surface, and we were going to put back material, essentially rock, and we were going to compact that material to where this kind of trapezoidal shaped piece of real estate that we were going to build was going to basically hold back, or what we would call a buttress. We were going to buttress the landslide. And so that was the idea here. And so this is just just a zoom. This is a zoomed in portion. So here's this buttress, and we'll see some pictures of that. So that's just kind of that area zoomed in. So we were going to come in with a contractor. We're going to excavate the toe of the material. And this material and we use the expression keyed in below the failure surface. So this will be below the landslide failure surface. And essentially this, in conjunction with some dewatering of the landslide, was going to, at least based on our slope stability analysis, was going to stabilize this landslide. So here's the big hole in the ground that we had to, so now we've got our backs to the hillside. We're looking out towards the river. And this is the excavation that we performed. And the idea was that we would put back heavier material that was more dense, because of its engineering properties, had enough strength that it would buttress the landslide. So here we are now looking to the north, the highway's on the left, the landslide that we saw in that aerial photo goes up the hillside on the right. And we're bringing in this crushed rock material, which is heavier and stronger than the landslide material, and therefore, would afford us this ability to buttress the landslide. One thing that I'll say is that when we dug this excavation, the landslide actually accelerated. So we went to, which we expected. So we ended up working 2 12-hour shifts, or the contractor did, and this was all monitored, meaning we had real-time monitoring, and we knew the depth of the failure surface. And once we excavated below it, we saw an acceleration in the rate of the movement of the landslide. And that's when we went to this 24/7 operation and, promptly put this material back as fast as we could, because we didn't want, the landslide to fail into the excavation. There was due to contractor safety. But once we piled this material back up, the landslide stopped. There was a little bit of excitement. Here's this outer face of this buttress. Sorry, that was kind of fast. So just more rock, bringing in lifts, compacting this material. This is a sheep's foot. This is a piece of equipment that's used to compact that material. So we just, and I got one more photo, I think. Yeah, so this is this big buttress. So now people probably whiz by this 4-lane section, and hopefully not on their cell phones. They're doing 65 and they don't even know this is here, but this big, kind of inconspicuous mass is a buttress that's holding back that landslide. So that's an example of stabilization. And let's see, 12:50. I think we're doing pretty well here. So drink a little
And you
water.
have until 1:30, Charlie.
Yeah. So
But there are a couple of questions.
Yeah, perfect.
Where is the material removed from the landslide taken is one, and have you adopted quadcopter drones for surveillance? And
Yeah.
could you talk about sinkholes? That's 3 different questions.
Sure. So let's see. The first one was like, where do you haul the material? Was that
Yep.
the first one? Yeah. Anywhere we can. That can be an enormous challenge, and it can be an enormous expense. And in this part of the world, the thing you need to be careful of is you need to really look carefully at our disposal sites, because when you start moving hundreds or thousands or tens of thousands of cubic yards, in the case of Confusion Hill, which was about 500,000 cubic yards, when you try to find a home for that, you have to make sure it's in a stable location so that you don't create new landslides or instabilities as a result of taking all that material and placing it somewhere else that's potentially unstable. So, we work with private property owners. Sometimes depending on the nature of the construction contract, it becomes the property of the contractor. So, it might sound like I was being a little flippant when I said anywhere we can take it, but literally, sometimes if it's rocky material, the private timber industries is interested in it because they can reduce it in size and use it to rock their logging roads. Sometimes ranchers might have large flat expanses where they want to create a flat building pad, if you will. Like, they might have some big swale that they want to fill in so they can create a large, flat usable space. So it really just depends on where we are in Humboldt, Elnart, Mendocino, or Lake County, and then what's in close proximity. And usually we want to deposit as close as possible because trucking can be such a huge cost that the shorter the trucking distance, the less expensive it's going to be to deposit that material. Um, and then there was a question about quadcopters. Yeah, we have at Caltrans and even here in my branch, we use drones extensively now. We do, yeah, we are definitely, I would say, on the cutting edge of drone technology. We have some sites, one down in District 5 on the Big Sur Coast, where we literally fly a drone every single day, and you can compare that imagery to from one day to the next. And that's one way that we kind of monitor some of these large active landslides on the Big Sur Coast. But yes, absolutely. I'm trying, I don't think I have any drone. I'd have a drone image in later in this presentation, but yeah. Drones have really revolutionized how we do the work we do. And so, I said with this last example I gave where I drove up and I'm standing there at the road and craning my neck back, wondering how long that landslide is. I hike halfway up to realize it just went another 1,000 feet up that hillside. Now, some of the first people to respond to these, along with myself and some of my colleagues, are the technician on our staff, who's a very adept drone pilot. And what used to take us all day to gather, in some cases, some areas in the district aren't even accessible by foot because it's so steep, requires being on ropes. But with drones, it's really made our lives a lot easier. So yeah, absolutely. We use drones extensively. And then what was the third question?
Where did the third question go?
Let's see, it was
That was, could you talk about sinkholes?
yeah, sinkholes. So I'll just keep it in the context of the ones you might see in the roads around here, because because there are geologic environments around the world where you have what's called limestone.
A
Um,
friend of mine fell in a sinkhole in Albuquerque. That's why I'm asking it.
that's funny. Yeah. So
Not funny. It was his beautiful car
well,
that fell in.
yeah. Well, oftentimes what happens is there's I'll just keep it generally speaking is that some geologic units dissolve, like particularly limestone. You can have limestone, which can be prone to dissolution due to groundwater flow. And over time, you have these caverns that can grow and enlarge. And I think there is a really famous Corvette museum in
Oh
somewhere
yeah, in
where
Kentucky.
essentially, and they call it karst, I believe it's called karst topography. I'm just drawing a blank, but where basically, due to dissolution of the limestone, due to groundwater or seepage, you can create these really large caverns beneath the ground, and you don't know it typically until it's too late. And sometimes you can imagine if you have this large cave uh, a short distance below the ground surface, and if you have any kind of infrastructure, house, you know, excuse me, Corvette Museum, uh, sitting on top of that, oftentimes they can fail very quickly and suddenly, and then whatever's sitting on the surface will fall into that cavern. So um, they do have, excuse me, they do have geophysical techniques. Give me 1 second, please. I was afraid, I was afraid I might not make it. Let's see if I can.
Take whatever break you need, Charlie.
There we go. That's better. So there are geophysical techniques. That's a fancy word for remote sensing, where there's something called ground penetrating radar that can be used in advance to check for for example. Uh-oh. Uh-oh. Give me 1 second. Hold on. There we go. I'm gonna take 1 second and I'm gonna be right back. Hold on.
Go ahead.
Yeah, perfect. I just need to.
We're very appreciative of all your doing this when you're not feeling well. It's lots of questions and lots of interest. if we get a chance, I'd love to have him explain how landslides in the water under the ocean can cause tsunamis. And I think that's one of the major things that happened in Japan. But it's also been a cause of tsunamis.
Yeah, it's called displacement. So the land moves, it displaces the water becomes a tsunami.
Right. It's fascinating. Thank you, Patricia Ann, for filling in the blank.
Whew. All right. I'm back. I think I've rectified it for the moment. I'm sure everybody's had the cred at some point. The good old Humboldt cred. Anyway, yeah, so yeah, karst topography, limestone is I think the typical culprit. But yeah, it can be very problematic. And if you just Google um, sinkholes, there's all kinds of information on the internet about where they occur or are more frequent based on the geology. And yeah, they can be a real problem. I've seen in terms of mitigation, oftentimes they just fill them in, which might sound a little simple, but once it's occurred, oftentimes they have to fill the hole essentially, if they want to reuse that space. And like I said, there are techniques that can be used to detect developing sinkholes before they actually, not before they occur, because you'd have to have the foresight to want to do it. But when you start seeing settlement in some of these environments that are prone to sinkholes, oftentimes they will, in a proactive manner, go out. You can map them using certain geophysical techniques. In terms of sinkholes that you might see in our highways, oftentimes it's either due to, oftentimes we'll have landslide movement where as the landslide begins to move, it creates holes or caverns, cracks, fissures below the asphalt, and then you'll see the asphalt start to fall through into these cracks that are developing in the subsurface. But probably more commonly, it has to do with our culverts. And so there's, I don't know how many tens of thousands of culverts, um, drains that drain surface water underneath the highway to the downslope side. And over time, they rust to where they oftentimes can collapse. And then once the culvert collapses or the groundwater or the water that's being transferred through them winnows away, it removes the fill below the highway. Oftentimes, that we get sinkholes in the highway from basically failed drainage systems. So yeah, but yeah, they're kind of their own unique problem, which are fun if you like geohazards.
You have a question. How do you measure cohesion?
How do you measure cohesion? So cohesion is something that we associate with what we call fine grain soils, like clay. And so there's once you can identify the clay mineralogy, there's a lot of published values that we can use. In terms of how many tons per square foot in terms of its shear strength. And then you can estimate the cohesion value. And there are what's called a torsional ring shear test. There's a number of lab tests that you can do that will allow you to estimate the amount of cohesion. In terms of just simple field tests, there's some hand techniques when we have people that are out what we call field logging. We perform a lot of what's called geotechnical drilling, where we're drilling holes in the subsurface, we're retrieving samples, we're describing that in the field, and based on some characteristics of how elastic it is, and if you dry a sample, how hard it is to crush it between your fingers, you can use a lot of these different techniques to ultimately estimate the cohesion.
And then why put soil on fabric?
The reason the fact it was that maybe from that picture was that oftentimes we try to separate. Let's see, that's a really good question, and there's my mind's racing because there's a lot of different situations where we might want to use fabric. So sometimes we use fabric because we're basically the simplest way to describe it is we're trying to intentionally trying to have a boundary. So like, and why would we want a boundary in the subsurface? In some cases, we might have a lot of groundwater that's going to be flowing through a particular engineered soil structure, if you will, and to try to, and we might want to maintain a certain permeability and to preclude what we call the migration of fines. So as the groundwater percolates through this embankment, it may carry a lot of clay-sized material into the pore space. And oftentimes, things that we design to be free draining, if all those little pore spaces get plugged by clay-sized particles, then it's no longer free draining. And then when it's no longer free draining, then it can retain water. And then not only does it increase the weight of the material, but then it can reduce the shear strength. So, and then in some cases, if we're placing rock, like large, we call it rock slope protection. You probably see it. You see it on a lot of our highway embankments, both above and below the highway, and you see it on a lot of county roads. Oftentimes, we'll put fabric down before we place the rock, because the rock has so much void space. What we're trying to avoid is we don't want to have the adjacent slope, basically due to, again, the movement of groundwater, surface water basically erode and migrate. It's not going to hurt the RSP, but by placing RSP next to this soil, we've basically are giving that soil the opportunity now to migrate due to surface and groundwater flow. So we're trying to preclude that from happening. So usually it's trying to create an intentional boundary because we don't want geologic materials or soils or drainage to affect our design.
Okay, could you briefly explain what is blue goo and how big a problem it is here?
Yeah, so so blue goo's kind of I've used the term, it's kind of an informal term that's used to describe some of the sheared clay-like, not clay-like, but so a lot of the geology in this part of the world is the Franciscan complex. People may have heard that term before, the Franciscan. There's a series of belts. There's the Eastern, Central, and Coastal Belt Franciscan. Within our broader geologic units here on the North Coast, oftentimes there's areas that we call the melange. The Franciscan melange is a term people might hear, where essentially the rock has gone through some serious shearing through tectonic processes and earthquake activity. And so once the rock becomes sheared, it's basically, maybe a simple way to think about this is it's like pulverized into this fine clay-like material. And oftentimes, due to the mineralogy of the rocks, it can have uh, kind of a blue-green appearance. And so oftentimes you'll see, and it's notorious. And why has it got its own name and why you hear about it? It's because these clay-like materials have what are called low friction angles, meaning they tend to fail on very gentle slopes. So if you've got like in the Sierra Nevada, if you have intact granite, you can essentially, through excavation means, cut it vertically in some cases, and it's going to stand vertically. But if you were to, and I think oftentimes what happens to property owners and construction folks in this part of the world is if you unknowingly cut into the blue goo, which might like to hover around anywhere from 12 to 23 degrees depending on the material, meaning it's happy if it's at a 18-degree slope, but if you try to cut it at say a 45-degree slope, then you've essentially exceeded its friction angle, and that material, when it becomes wet, turns into this very gooey mess that likes to flow. Some good examples is if you go up to State Beach in Trinidad, and this is true of a lot of our beaches in this area, is that oftentimes you'll see kind of this bluish green, it almost looks like modeling clay. And if you take a stick, our boys used to love to do this as kids, is that you could take a stick and literally like push it, several feet into this clay, saturated clay material called blue goo. And so it's basically, in simplest terms, it's clay that is here in this part of the world due to the tectonic processes that have basically formed our landscape, and also due to chemical erosion. And so now we have these in some places, very extensive clay units that are notorious for landslides and slope instability because of the nature of the material. and they like to hold water. So once you add water, then the friction angle drops even lower, and it can be a real headache. And it's really hard to work with, so it's a real nuisance. So that's kind of the blue goo. Hopefully that helps.
So the rule is you want to make sure it's 15 degrees or less.
I'm just trying to think of some of the lab numbers we've got on the friction angles that we've calculated based on lab work for some of these. Because oftentimes, with a lot of our landslide mitigation, some of these large landslides are failing on these clay units. There's some interesting. Um, Actually, it's funny that I could go on about this topic because recently I've been in communication with a lot of other geologists locally about, with some of these large landslides that have been moving for centuries or thousands of years, is the clay unit on which they're failing a result of years of shearing associated with that landslide moving, or was the clay layer there and that's why the landslide's there? And it's just I don't know if that makes sense. Like I guess it's just
Is the
I
cart before the horse?
yeah, I digress. So, there's so much of these clay units in these areas. Is the landslide there because the clay unit was there to begin with, or did the landslide occur and then overdue to centuries and thousands of years of shearing that occurs along the base of that landslide as that mass moves, you can imagine at depth. And in some cases, these landslides are 300 feet deep at 300 feet below the ground surface. The forces would be so great that any of the material that's within that failure zone gets sheared and almost, into these clay shear zones where they get imbricated. And so, but Gene, your question, yeah, I mean, if we know we're dealing with blue goo, then we're not having unsupported cuts. You're building retaining walls, and you're trying to remove that material. You're putting a lot of steel and concrete in the ground to hold those slopes back because almost can't cut them flat enough to where they're at a stable slope ratio.
I haven't noticed that you plant vegetation. Do you do that?
We do. That's not in my realm, so we do have landscape architects. You know, uh, and I think that they do have revegetation plans for large earthwork projects. So I don't know how much time people spend down in Lake County, but Lake 29 Expressway, that was an enormous project that I think just was completed a couple of years ago. Um, there was, it had an enormous footprint and there was a fairly extensive revegetation plan. So if you see slopes in, say Humboldt, Del Norte, Mendocino counties that you don't see a lot, if you don't see trees growing out of them, typically I think because we try to minimize impacts, meaning, um, so Caltrans has a certain amount of right of way, and we have a lot of private property owners that own the property adjacent to Caltrans right of way. And so we, generally speaking, try to cut slopes as steep as they are geotechnically feasible, meaning we try to cut things steep because the flatter you make our excavation slopes, the greater the excavation volumes, the greater the impact, the more material you have to haul off, and the more expensive it is. Um, and so oftentimes some of the slopes that we cut as part of our highway realignment, we don't do a lot of new construction anymore. It's a lot of like, curve corrections or landslide mitigation is we tend to try to cut things fairly steep. And so I'm not sure if it lends itself to, being forested necessarily, but we do have landscape architects. We do some re-veg. We don't typically use re-veg as a mitigation technique. There have been some projects where we do bioengineering, where we basically incorporate willow into the actual mitigation strategy so that we try to get some strength from the root strength. If when the willows can grow into, say, like this rock slope protection, it's kind of more of a holistic bioengineered approach. And there are people at Caltrans that are starting to spend a lot more time and energy in looking into what they call bioengineering. But generally speaking, what you see is they do grasses. And so you'll see them spray this oh, what do they call that? I'm just drawing a blank. But oftentimes, if you see a recently excavated slope at Caltrans,
It's
it's
green.
yeah, it's typically rare that you're going to see somebody hanging out there, planting, seedlings, but they will just spray it with and I can tell you that more often than not, they oftentimes it takes special sourcing, and they have like 7 native seed mixes. And so I know there's a lot of time and energy that goes into figuring out those seed mixes for the grasses. And I think those are there's permit conditions too. So for us to get permits from various entities, we have to meet certain criteria. So I think there's a lot of external agencies that oftentimes have a say in what we do in terms of re-veg. So hopefully
I have
that.
a, I have a question about a lot of these services are state funded. I don't know to what extent it's federally funded and to what extent the federal funds have disappeared or dissipated.
Yeah, so we have projects that are both state fund, they call it state funds only, and then but then we also a lot of our storm damage projects, which constitute an enormous amount of the work that we do here in District 1, is federally supported. So let's see, our Caltrans fiscal year goes from July 1st through June 30th of the subsequent year. And so we're how many months into this fiscal year? I have heard that there's, rumors that, we're probably going to see some reduction in funding, but I think most of Caltrans funding probably is, state. But again, it's the federal dollars that we use to do storm damage response. I will say that we did hear recently that um, what happens is when we get extensive storm damage on the North Coast, um, if the damage is widespread, there's something that's called a federally declared event. So some federal agency or federal highways will acknowledge it's like this is a significant storm damage event, and it costs, tens to hundreds of millions of dollars to go out and make all these repairs possible. Then they make a commitment to Caltrans to say, if you can deliver it within such a time frame, we're gonna pay for that work with federal dollars. And so I have heard recently that there's some concerns that it may be harder to get those federal dollars for this coming winter. Now,
Is that going to affect the tunnel?
yeah, and the tunnel's not, so the tunnel is a constant. I think the current estimate's something like 3 billion. I think we, Caltrans, are funded now through the design phase of the project. So Caltrans has basically been trying to collect funds as we go because nobody has a checkbook that they're going to write a check for $3 billion. So I think if I recall correctly, we, Caltrans, are currently funded through the end of what we call the design phase. So that would be to where we have a set of plans that we can begin construction. But it's the construction dollars that is that enormous price tag of, it was 2.1, now it's up to 3. I don't know where Caltrans stands at the moment in terms of, you know, trying to pull the funds together for that. But yes, I mean, I would expect that that's probably going to take an act of Congress, just from working on peripherally on large projects in the past of something of that magnitude, that usually takes an act of Congress to pass an appropriation that large for federal highways to, you know, Caltrans has a big budget, but, we don't have $3 billion available for one project. So that certainly is a concern for last chance grade. But we also need to consider that, that project's not slated to go to construction until optimistically, I feel like, if all goes as scheduled, I think it's scheduled to start in 2030. So what is this, 2026? So, we still have some time to try to pull those funds together. So we may have a different administration when that project goes to construction. And but I don't think we'll start construction unless they have the full amount. So that's a big number.
Yeah,
So
it is. Do you
yeah.
want to go ahead with your PowerPoint? We
Yeah,
didn't
yeah, and
any questions.
no, we're good. Well, and this one's pretty short. We're kind of down the home stretch. So the last kind of mitigation approach I mentioned earlier is protection. So this really applies more to rockfall. It does apply to debris slides as well. But so I started with avoidance. Man, if you can avoid the problem, that's probably your best bet. And then there's stabilization. I just kind of gave an example of a large landslide where we actually stabilized the landslide by building a buttress, and then protection. So I'm going to take you back to Highway 96. That's definitely a tough neighborhood out there. So this was an existing cut slope, a slope that had been excavated to build the original highway. Maintenance started noticing not a little bit of rock, but a lot of rock on the highway. Pretty significant. And here's a picture of what the inboard ditch looked like. So, major safety issue, right? So not good situation. So I don't expect everybody to read all this, but I'll just run through this quickly. It was really more for me, but basically, we have received 4 inches of rain, in about 5 days back in 2010. And then we had a rock slide occurred around 7 a.m. on a Saturday morning, and it deposited about 40,000 cubic yards of material on the roadway. And then the rock slide, it reactivated, meaning there was an older landslide above it that became active as a result of this. And the headscarp of this other slide was 230 feet above the rock slide. So this was, again, show up and what are we going to do? It's like, man, I don't know. It's a tough one. So here's an aerial image of Highway 96. You can see this was the old cut, this light colored material that doesn't have any vegetation. That was the original cut to build the highway. But then we had this large delineated in red, that's kind of the limits of the cut slope failure that occurred. This huge rock slide that buried the highway and actually went all the way down to the Klamath River. And then the area between the red and the yellow lines is a piece of real estate that moved in response to this rock slide. So not only did we have this mess, not only did we have this mess to contend with, but then we had this piece of real estate which had basically become active as a result of the loss of material. And this is just a zoomed in. I think I've referred to a couple times like the headscarp. So this kind of oversteepened area here, this white, is kind of there was an existing scarp there, and as a result of the rock slide in red, a portion of this older landslide reactivated. So, long story short, we monitored that slope for a long time and convinced ourselves based on the data that the landslide above the rock slide had really removed in response to the rock slide, and this was now stable, but we still had this pile of rock on the roadway and this steep, recently failed slope to contend with. So a lot more. I hope you like rocks because I got a lot of pictures of it. But this is what it looks like from below. So you can imagine, like, this is not somewhere that you probably want to be driving a vehicle is under a slope that looks like this. So we thought, well, what are we going to do? We really didn't want to go to the top and re-excavate the whole slope because of the volume. There was also some cultural considerations. This is out on Highway 96, so there were some cultural considerations. We had this marginally stable piece of real estate on the hillside above. We weren't going to build two bridges to go onto the opposite side of the highway. It just wasn't possible at this location. So we were like, well, so stabilization was probably not really an option, nor was avoidance. And here's just, you can appreciate, this is some pretty tough terrain here, and this is not something you want to be running traffic under. So that's a cross section, which I'll skip for now. But we monitored the site. We used kind of an old method where you just there was a crack here that was opening up, and so we put lath in the ground and we go out there and measure how far we take it, this is kind of old school, and even with all the technology we have today, this is still really tried and true. As you go out there and you mark on this horizontal piece of wood with a Sharpie, you can mark it and put a date. And then as this crack opens up, you can basically tick off as that crack opens up. Forgot this slide was in there. But anyway, so we might use that. We also use survey prisms. So we actually monitored this slope during all these activities because we didn't want anybody out there working underneath this slope if it was potentially still active. So we had a I didn't really touch on that today, but there's all these things that we have to do to ensure the contractor's safety to try to mitigate these landslides. So we had monitoring survey things that we could read from the opposite side of the river with a total station, and we have these survey monitoring points. But we decided that the best approach would be to remove as much of the loose, unstable material as we could, remove the material from the roadway, and then, but we were still going to have a rockfall issue, so we needed some protection. So this is what's called hand scaling. So we hired a specialty contractor that actually went out and removed some of these rocks by hand. Believe it or not. Here you can see some vehicles down here on the road for scale. So yeah, these people specialize, this outfit that we hired, they specialized in what's called hand scaling. So it's very labor intensive and very time consuming, and it's dangerous, but we take precautions. So there's hand scaling. We remove the material from the roadway using excavators, but you can see how ugly this slope is still above the highway. More material on the road. So we actually used a logging technique for using an excavator and cables to drag what we call the shark up and down the face of the slope. So this is a I-beam that's made out of steel with a bunch of teeth that are welded to it. And I'm just demonstrating this so you can see that there's a whole system of cables that we're using a yarder from the logging industry for people that might have been loggers. And we literally dragged the shark back and forth and kind of raked this thing across this slope. And this is what came down as a result. So we're trying to basically remove as much of the unstable material as possible. So when we were done with the hand scaling and excavating the material at the roadway and using the shark, this is what it looked like. But we weren't, but there's still a lot of loose material on the slope. So we weren't going to open it up to traffic and run traffic underneath this slope, particularly in wet weather. And we did the best we could to kind of, I'll say, stabilize it loosely. So we
It's
needed,
like triggering a rock avalanche.
yeah, I mean, this, when this gets hit with rain and it was a recently failed slope, it's just going to rain rocks down on the road, and we don't want that. So we want it to be safe for people to be able to drive through here in the winter. So we decided we were going to go with what we call protection. And that's really what this example I wanted to share is that we did take steps to stabilize the slope as best we could, but really the main point was that we were going to protect it. And this is what I call these shower curtains. So we have what we call a cable mesh, which is like a shower curtain that we place over the slope, and then it's suspended by, in this case, suspenders and cable anchors at the top. And then as rockfall is generated behind this, it is conveyed below or behind that shower curtain, and then it controls the trajectory and the velocity and the energy of that rockfall to where it can be managed at the roadway level by it gets spit out behind some K-rail, and I'll show you a picture of that. But so this was our idea. But in order to get to this spot on the earth to put in this ground anchor, this is what it looks like. So in hindsight, I'm the one on the red rope taking this picture, and I think in hindsight, I can't believe that I rappelled down this slope, but I'm glad I'm here to talk about it today, and I probably wouldn't do it again, but this gives you an appreciation for how challenging some of this work is. And so we have rappelled down to these anchor locations. It required a use of a very large crane. So this is a view from the top looking down. Here's a view from the roadway looking back up. And so they're hanging these panels, and then there's people that rappel down and stitch these panels together with lacing cable. So we have a nice big continuous, there's another picture, but you can imagine the expense and the effort to do this work. And then when we're all done, we have, the lower portion of this slope is covered with this cable net drapery system. And then we have K-rail at the toe, which is a fancy, some people call them Jersey barriers, but it's this steel concrete barrier. And then we have this, what we call like a little catch fence. And then periodically maintenance comes over, and we have a little mini excavator that crawls around behind here and loads the stuff out. But that was an example of protection. Oh, and I guess I got one more. Management. Did I? I guess I didn't. How much time I got?
Well,
Well,
just keep going to as long as
yeah,
people want to hear you, you can keep going as long
yeah,
as
okay,
you keep
yeah.
talking.
Yeah, well, and here you go. So management. So I guess I forgot about management. So management, sometimes landslides are, we can't avoid it. It's really not feasible to stabilize. And there, in some cases, it's really hard to protect. So, what do you do in those situations? It's still our responsibility to keep the highway open in a safe manner. So we kind of sometimes it's a combination of stabilization, protection, and avoidance, but we're actively managing a site. And so this is out on Highway 36. This picture was just taken recently from a drone. Somebody asked about drones earlier. So some of you may be familiar with this landslide. It's about post mile 15. It's before Bridgeville, but this is a menace. So it's very long in terms of the slope length. It's very steep. And what you don't see in this photo is that the headscarp, remember the pictures I was showing you about the headscarp, is like well up into these trees. And the concern is that if we came out here and tried to remove this loose material, it's so steep that we would just undermine or destabilize the hillside above. So we're very concerned about trying to remove the failed material or this landslide. The amount of material that this thing keeps spawning or shooting down on the roadway exceeds our ability to put up like a fence at the roadway elevation. It's just been a real nightmare, frankly. And so, so last spring when this thing finally settled down, we thought critically about, what are we going to do before meeting this winter that right now to be able to maintain traffic out here, because for people that live out on Highway 36 or work out there, um, there aren't really a lot of viable alternatives in terms of detours. There are other ways to get out there, but it's a challenge to say the least. So this was really a combination. And when I say management, so we're kind of taking a hybrid approach is that we basically realized that we had to avoid this landslide as best we could. So we actually built a large rock embankment towards the river. And mind you that this whole slope below the highway had already been denuded of all vegetation due to the landslide going over the roadway and basically going directly into the river. So we basically took a lot of the slide debris, a lot of the rock that came down from the landslide and adjacent landslides. You can see one here on the right, and there's another one around the corner on the left. And we basically built the embankment out away from the existing highway alignment so we could create space between the toe of the existing landslide and the highway. And we've reduced the highway's width from 2 lanes to 1 lane. So this is avoidance. So we're basically trying to avoid the problem by realigning the highway, and then we're trying to protect the highway by building what we call a large earthen berm. And let's see if I got a picture of that. So here's a cross-sectional view. So you have Indusen River on the left, landslide on the right. The highway used to be, you see where this tree is in the center of the photo, actually where the yellow tree is here, and the highway used to be right at the base of the slope. So it was probably 30 to 40 feet further to the right. And so anytime material came off this slope, it was immediately into the roadway. So we basically realigned the highway towards the river, pushed the road out, a single lane out towards the river, and built this large earthen berm using the materials that we have on hand. And so this was after the first significant rainstorm the week before last. And basically, we were able to maintain traffic throughout that entire rainfall event, and all the landslide debris was contained within the catchment area behind this earthen berm. And so, and I'm saying management. So this site requires a lot of management. So the first clear day we had, which was, I believe, last Monday, a week ago, this past Monday, we had an excavator out there basically removing all the material that had accumulated in the ditch. And I just got a call this morning that with last night's rain, the ditch is now filled up again. Fortunately, tomorrow we have a good forecast in terms of clear weather, and they're going to be back. Excuse me, they're going to be back out there tomorrow, cleaning out this catchment area. So when I said management, this site is being actively managed by Caltrans right now. Yes, we have this protection in place. We tried to avoid it, but management is an approach to landslide mitigation, but it's usually when other alternatives aren't viable. And maybe I'll just wrap up by saying last chance grade would be a really huge example of management, whereas for the last century, since the highway was built at last chance grade, Caltrans has been building retaining walls and putting in drainage systems and realigning and paving and grinding, essentially just trying to keep that road knit together as it rides on the back of this large coastal landslide seaward. So, there are a lot of relatively small projects at last chance grade that involve stabilization, but in the grand scheme of things, it's really management where we're just basically, to the best of our ability, trying to manage the risk associated with landslide hazards to be able to keep the road open. So I think that's it.
Charlie, one
Yeah.
last question from
Shoot.
Bruce. We have all been watching the construction of the Indianola overpass.
Mhm.
The side slopes look pretty steep. Can you explain the planning that went into preventing the side slope from sliding in the rainy season and their use of these big blocks of styrofoam?
Yeah. Okay. Good question. So maybe I'll start with the styrofoam. So, so obviously, well, maybe not obviously. So that intersection is in the middle of Humboldt Bay. So, as many of you may know, Humboldt Bay used to extend much further inland. It was diked and drained to create, grazing land for cattle, is my understanding. But, for all intensive purposes, Indianola, that intersection sits in the middle of Humboldt Bay. So the soil beneath that intersection is predominantly clay, very soft, very squishy, very low strength, and so supporting the bridge. And I'll get to the EPS, the expanded polystyrene blocks. So the bridge itself is on very deep piles. So we had to go extremely deep to be able to get enough support to support that bridge in this clay material. And then we have this very large, what we call an approach fill or embankment that obviously is required to get up to the top of the new bridge. And in order we use the term isolate. What we didn't want to have happen is we didn't want to have the load from the embankment have any influence on the foundation for the bridge. So basically, you can imagine you got this big squishy trampoline almost, and we're trying to isolate those two things from one another. Like we didn't want the embankment load on those squishy soils having an adverse effect on the foundation for the bridge. So we basically were able to isolate the two, meaning keep them further enough apart, like, two kids wrestling on a playground and, the woman's got one, or the guy's got one kid in one hand and he's got one kid in the other hand. And he's like, all right, I'm going to separate you two. So we decided we would separate the embankment from the bridge by placing expanded polystyrene blocks, those large blocks in between. And so believe it or not, those blocks have enough bearing capacity when they're confined that we can run traffic over them, but they weigh very little. And so we were able to effectively isolate the embankment from the bridge foundation by making the transition from the embankment to the bridge using these expanded polystyrene blocks. So that's what all those blocks are for. In terms of the side slopes, we have what's called select material. So the specifications for that embankment, meaning, when we put together a project and it goes out for bid, there's specifications. The specifications for the material that's required to build that embankment were designed such that the slope ratio or the slope that's out there for those side slopes are deemed adequate for that material. So, unless there was I'll just say that those side slopes should be appropriate for the material that they're constructed with. So we did not use bay mud or clay or blue goo to construct that embankment. All that material was imported and had to meet very specific criteria so that it will stand at that slope ratio. So we might see some, yeah, we might see some shallow, you might see some shallow, erosion, rilling and gullying, which might be inevitable unless the grass, takes better hold. But we shouldn't see any, significant failures of that embankment. A little bit of erosion, I certainly think is reasonable to expect. Now, if we do see a failure of the embankment, then it might have been the source material didn't meet the requirements, or there might be something else going on. So
Yeah.
fingers crossed. Mother Nature bats last, so I'm always cautious.
Charlie, you've been absolutely wonderful. And people say, wow, so fascinating and well presented. Thank you, thank you. And I thank you, thank you.
Yeah, well,
I would
we're
love to introduce the concept of, can you take one of those escarpments and put a great big French drain around it to stop the
yeah,
water
well, one
and
of the
rechannel it so it doesn't fall down the slope?
yeah, one of the alternatives, I'll just mention that subsurface dewatering. So, one of the alternatives that was considered for last chance grade was actually dewatering, which is kind of hard to imagine dewatering, a mile-long stretch of highway that's all supported by it's basically on a large landslide. But Highway 1 down near Westport,
Hey, I'm so sorry. We are quite a bit over time now, and I do
let's
have
wrap
to
it up.
close the meeting.
Yeah, no worries. Thank you I'll go on all day because I'm passionate about it. But I hope people found it interesting. My sincere hope that people learned something today. And if you have burning questions, maybe you could direct those to the OLLI crew and they can forward them to me. But I appreciate your time today. Thank you so much. And just know that we're doing our best to try to keep it open and safe for everybody. So
We really appreciate all you're doing and thanks so much.
yeah,
Thanks,
Jane,
Charlie.
thanks so much.
I hope you feel better soon.
Yeah, me too.
Yeah.
I'm getting there. Thank you.
You're amazing that you've got